Hello everyone. In this short video, we're going to look into the two different types of memory elements, which are the latches and flip-flops. As we recall, memory is classified into two types, latch and flip-flop. A latch is classified into two types again, which are the positive level latch, for which the output changes when clock is 1, and the second one is the negative level latch, for which the output changes when clock is 0. On the flip-flop side, we have two types again, which is the positive level rising edge flip-flop and the falling edge flip-flop. The rising edge flip-flop changes when the output is changing from 0 to 1, and the falling edge flip-flop, the output changes when my clock is changing from 1 to 0. In terms of types, there are multiple types. The first one is the SR, the second one is the D type, the third one is the T type, and the fourth one is the JK. So again, from this SR, we have SR positive level latch, we have SR negative level latch, we have SR rising edge flip-flop, SR falling edge flip-flop. Similarly, in D, we have D positive level latch, D negative level latch, D rising edge flip-flop, and so on and so forth. But for the interest of time, in this video, we're going to look into only the SR and the D positive level latch and rising edge flip-flop. Now, let's look onto the page on the right. I have a schematic for my SR level latch or SR level flip-flop. Let's say it's one and the same. This is an SR level latch, and on the right I have a simple symbol for SR level latch here as well. So now let's look here. On the right side, I also have a truth table which shows the function of my SR level latch. So here, as you can see, when my S is 0, R is 0, my output would be the same as previous case here. When my S is 0, R is 1, it works like a reset. So you hit a reset button, your output is going to be 0 all the time. On the third case, when S is 1, R is 0, it's setting your output to 1. And the fourth one, which is 1, 1, is an invalid state. So let's keep it aside. So we are concerned about three states, 0, 0, 0, 1, and 1, 0. Now, on the bottom, I have a simple waveform for SR, and my C is my clock. I want to draw these latch output and the flip-flop output. So let's look here. For latch, when does the output change? The latch, we have a positive level latch, so output changes when clock is 1, right? So what happens when clock is 0? It retains the previous value. So let's see here. My clock is 1 at this time, during time 1 to 2, during time 3 to 4, during 5 to 6, 7 to 8, 9 to 10, and so on and so forth. So what we need to do here is just look into the output only at this point of time. So initially, let's say my Q output is 0. So at this time, see here, during this time, what is my reset here? Reset is 0. My set initially is 0. So 0, 0, what is my output? The previous value till certain point. So now my set is changing to 1. When my set is 1, reset is 0. What is my set is? See here, set is 1, reset is 0, 1, 0. So output is 1, yes. So output changes to 1, and it goes on till the next time when my clock is changing to 1. Now let's look here. When my clock is 1 during this time, my S is 1, R is 0, 1, 0, my output would be 1, and remains the same till the next time clock changes to 1. Now let's look here. When clock is 1, initially set is 0, reset is 0, so it retains the previous value for certain time. Now at this point of time, from during this time here, my set is 0 and reset is 1. When set is 0, reset is 1, output changes to 0. So output changes to 0 and goes on till the next stage. Now when you come down here, again initially set is 0, reset is 1, so output is going to be 0. Later on, as you move forward, my set becomes 1, reset is 0, so my output changes to 1 and continues all the way and continues there, so on and so forth. Right? Now, how does the flip-flop change? The flip-flop, on the other hand, as I said, we got to look into flip-flop is again a positive edge flip-flop. So my output changes when my clock changes from 0 to 1. So now let's look here. My flip-flop, initially my output is 0. My output is 0, so output remains the same. And at this point of time, all what you need to do is you need to look into the value of S and R only at their rising edge, which I am marking here on the clock. So as long as we evaluate the input at only these marked edges, we should be fine. Let's look here. When at time 1, when my clock is changing from 0 to 1, what is my S and R? 0, 0. So 0, 0 output says is the previous value, right? So we retain the previous value till the next edge. We come down here. Now at time 3, what is my S and R? S is 1, reset is 0. S is 1, R is 0. So 1, 0, output would be 1. So output changes to 1, remains there till the next stage. At the next stage, my S is 0, R is 0. So retain that till the next value. At this point, S is 0, R is 1. S is 0, R is 1. From our truth table here, S is 0, R is 1, my output would be 0. So retain that till the next value. Come down here, S is 1, R is 0, so my output changes to 1. Goes on till the next stage. Now coming down here, my S is 1, R is 0, again the output continues till the next point here. Okay, and this continues forward. Let's look into a different type here. D is even very simple here. Forget about the schematic here for a minute, what I gave here. Okay, just look into the symbol and the truth table. As you can see, at D, the truth table, all what it says is when my input is 0, my output, my mistake here, it's a simple typo. So when input is 0, output is 0. When input is 1, my output is 1. As simple as that. So whatever is the input gets passed on. So let's look here. Again, for a latch, we are looking into the positive level latch. So my output changes when clock is 1. Now let's look here. For a Q latch, all what we need to do here is, see here, when clock is 1, my input gets passed on to the output, right? So all what you need to do here is during the time when clock is 1, which is the time from during this time, during the time 1 to 2, during time 3 to 4, during time 5 to 6, 7 to 8, and 9 to 10, and 11 to 12. During that time, whatever is the input D, it's just copied and pasted. So all what I would do is during time 1 to 2, my input is changing like this, right? So just paste that, and similarly come to time 3 to 4, my input is changing like that. So I would just copy and paste the input during that time. During 5 to 6, it is logic 1. During 7 to 8, it is logic 0. Okay, and during 9 to 10, it is logic 1. During 11 to 12, it is logic 0. That is step 1. And step 2, as you recall, my output remains the same when clock is 0, right? So from time 2 to 3, it remains the same, and time 4 to 5 remains the same, 6 to 7 it remains the same, 8 to 9 remains the same, 10 to 11 remains the same, and all what you need to do, step 3, is connect the breaks here. That is your D latch. The last one we need to look into is the D flip-flop, which we're going to look into a positive level flip-flop, right? So my output changes when my clock changes from 0 to 1. So let's look here. Initially output is 0, so all what you need to do here is capture the value of D when clock is changing from 0 to 1, which I'm marking here. There are, let's look here, 1, 2, 3, 6 times when clock is changing from 0 to 1. So during time 1, clock is changing from 0 to 1. What is the value of D? Which is 0. So retain that 0 till the next time clock is changing from 0 to 1. During this time, time 3, what is input D? Input D is logic 1. So change it to logic 1, retain that till the next time. At time 5, what is my D? D is logic 1, so retain that till the next time. Time 7, what is my D? D is 0, so bring it down to 0, retain that till the next point. At time 9, what is D? D is 1, so move on to 1, right, to 0. At time 11, what is D? D is going to 0, so retain that and move forward. And that is how you solve a simple waveform for a D latch or a D flip-flop or an SR latch or an SR flip-flop. We will talk more in detail about this during class on Tuesday. Thank you.